I will never look at airport runways the same way again. At first glance, they might just look like endless stretches of pavement, but there's a world of science and engineering hidden beneath your feet every time you step onto one. These runways are the unsung heroes of aviation, quietly enduring some of the harshest forces on Earth. They're not just long roads. They're engineering powerhouses designed for the wildest conditions. Imagine the weight of a fully loaded jumbo jet slamming down at over 150 miles per hour, or the searing blast of jet engines that can reach temperatures hotter than lava. Every inch of a runway is built to survive these extremes, day after day, year after year. Let's break down the secrets behind these indestructible runways. First up, runway material. The choice of what goes into a runway is a science in itself, and it's all about balancing strength, flexibility, and durability. It's not just concrete or asphalt. Airport runways are built with special mixes packed with rocks, sand, and industrial glue to handle the crushing weight of massive planes. These materials are chosen for their ability to withstand not just the weight, but also the constant pounding and vibration from thousands of takeoffs and landings each year. The mix is carefully tested and tweaked to make sure it won't crack or crumble, even after years of abuse. Some runways even have layers of metal mesh for extra strength. This reinforcement acts like a skeleton, holding everything together and preventing the surface from shifting or breaking apart. In regions with extreme weather, these metal layers are especially important. They help the runway flex slightly with temperature changes instead of snapping under pressure. But what about the insane heat from jet engines? When a plane is about to take off, its engines unleash a torrent of hot air that can easily melt ordinary pavement. The surface of a runway has to be tough enough to resist this heat, as well as the friction from tires screeching at high speeds. That's why runway surfaces are super thick, up to 3 feet deep in places, to soak up heat and stop cracks from forming. Underneath, there are multiple layers, each with a specific job. Some absorb shock, others spread out the weight, and the topmost layer is designed to take the brunt of the heat and pressure. The top layer is extra dense to resist melting, even when jets blast it with thousands of degrees. This density also helps prevent fuel or oil spills from seeping in and weakening the structure. It's a delicate balance. Too soft and it melts, too hard and it cracks. Now let's talk water and weather. Runways have to deal with everything from torrential rain to blizzards and blazing sun. Water is a major enemy. If it pools on the surface, it can cause planes to skid dangerously or even hydroplane. Ever notice grooves running down a runway? Those grooves drain rain fast so planes don't skid or hydroplane. The pattern and depth of these grooves are carefully engineered to channel water away in seconds, even during the heaviest storms. Plus, runways are slightly tilted, just a tiny slope, to help water flow off the sides. Even a difference of a few inches across the width can make all the difference in keeping the surface dry and safe. And lightning? Airports are often struck by lightning, but the runways are ready for it. Runways are grounded with metal rods and wires sending dangerous energy safely into the earth. This system protects not just the runway but also the planes, equipment, and people nearby. It's a silent guardian working in the background every time a storm rolls in. All that engineering keeps planes and people safe every single day. From the moment a plane touches down to the second it takes off again, the runway is working overtime to make sure everything goes smoothly. It's a marvel of modern design, blending brute strength with clever problem solving. Next time you fly, remember, you're landing on a true modern marvel. Beneath your wheels and feet is a masterpiece of engineering, quietly braving lightning, jet heat, and the forces of nature, so you can soar safely to your next destination.